In the year 2000, if you wanted to launch a satellite into orbit, you had one primary destination: Russia. The Soyuz and Proton rockets were the workhorses of the world. They were reliable, they were cheap, and they were the undisputed kings of the commercial space market. Back then, a young entrepreneur named Elon Musk walked into a meeting with Russian space officials to buy a refurbished ICBM. They literally spat on him. They called him an amateur. They told him his ideas about reusable rockets were a physical and economic impossibility. Why you need to watch this video until the end? Today, the roles have reversed. SpaceX launches more rockets in a month than Roscosmos does in a year. But the reason isn't just better technology or more money. It's a mathematical trap. By the end of this video, you will understand the specific variable of death that the Russian space program ignored, a calculation that turned their greatest strength into their ultimate weakness. Welcome to What, Where, and Why channel. Today, we dissect the business of the stars.
To understand why Roscosmos lost, we first have to understand why they were winning. The Soviet and later Russian approach to space was a masterclass in optimized attrition. The Soyuz rocket is essentially a 1960s design perfected over 6 decades. Its philosophy is simple: mass produce a single design like a T-34 tank. When you build thousands of engines, your unit cost drops. You don't care that the rocket is expendable, meaning it burns up in the atmosphere after one use, because you have a giant factory in Samara churning them out like sausages. For decades, the where was Baikonur, a massive, isolated complex in Kazakhstan. This gave Russia a logistical moat. They had the infrastructure, the rail lines, and the specialized workforce that no one else could match. Why didn't they build reusable rockets? Because historically, it didn't make sense. To make a rocket land, you have to add the engineering tax. You need landing legs, grid fins, extra cold gas thrusters, and most importantly, you have to save about 10% to 15% of your fuel just for the trip back down. In the eyes of Russian engineers, carrying 15% extra fuel just to save a cheap steel tube was a crime against physics. The Tsiolkovsky rocket equation, the fundamental law of spaceflight, states, in this formula, every kilogram of dead weight, like landing legs, drastically reduces your payload capacity. Roscosmos chose to maximize the payload. Musk chose to maximize the life cycle.
While Roscosmos was relying on a supply chain inherited from the USSR, SpaceX was building a blueprint of control. The Russian space industry is a massive web of state-owned enterprises. One factory makes the engines, another makes the fuselage, a third makes the electronics. These components travel thousands of miles by rail. This creates logistical friction. Every handoff is a chance for a delay, a bribe, or a quality control failure. Elon Musk applied the what of vertical integration. At the SpaceX factory in Hawthorne, California, raw sheets of aluminum and titanium enter one side, and a finished Falcon 9 comes out the other. They 3D print their own engine components. They write their own flight software. By eliminating the middleman tax, SpaceX reduced the cost of building a rocket long before they ever landed one. The moment the world changed, December 21st, 2015, Flight 20 of the Falcon 9. For the first time, a first-stage booster returned from the edge of space and landed vertically at Cape Canaveral. The why shifted that night. The industry realized that the expendable model was now like flying a Boeing 747 from New York to London and throwing the plane into the ocean after the passengers got off. Even if the plane is cheap, it can never be as cheap as a plane you can fly 20 times.
Now let's get into the mathematics that actually kill the competition. This is where most analysts get it wrong. They look at the price of a launch, but we need to look at the marginal cost. The calculation. A new Falcon 9 launch is priced at around $67 million. But what does it actually cost SpaceX when they use a flight-proven, refurbished booster? 1. Fuel, $200,000 to $500,000. 2. Refurbishment, between $1 million and $15 million, depending on the wear and tear. 3. Range fees and labor, $2 million. The marginal cost to SpaceX for a reused launch is estimated to be below $15 million. Meanwhile, the cheapest Russian rocket, the Soyuz, has a fixed cost. You cannot refurbish it because it's at the bottom of the ocean, or a Kazakh steppe. Its cost is the cost of building a new one every single time, usually around $45 million to $50 million. The Starlink engine. Here is the why that Roscosmos couldn't replicate. Reusability only works if you fly constantly. If you only launch twice a year, the cost of the landing legs and the refurbishment team is higher than the savings. SpaceX solved this by creating their own customer, Starlink. By launching thousands of their own satellites, SpaceX forced their rockets to fly every week. This high cadence allowed them to perfect the refurbishment process. They turned space travel into a high-frequency logistics business. Roscosmos, hampered by sanctions and a lack of private investment, has no Starlink. They have no high-volume demand. Without the volume, reusability is an expensive hobby. With the volume, it is a monopoly maker.
We've discussed the what and the where, but let's talk about the who, the architects of these systems. In Russia, the space program is a matter of national pride and state bureaucracy. Success is defined by not failing. If a state-funded rocket explodes, someone might go to jail. This creates an environment of evolutionary stagnation. You don't change the Soyuz because the Soyuz works. In SpaceX, the culture is iterative failure. They expect the first 5 versions of a rocket to explode. They view an explosion not as a tragedy, but as high-speed data acquisition. As we speak, the gap is widening. While Roscosmos is struggling to debut the Angara, a rocket that is still fundamentally expendable, SpaceX is testing Starship. Starship is designed for full and rapid reusability, not just the booster, but the entire ship. If they succeed, the cost of putting a ton of material into orbit won't just drop, it will collapse. We are moving from $5,000 per kilogram to potentially $100 per kilogram. This isn't just a competition anymore. It's a different era of civilization.
So why did Elon Musk beat Roscosmos? It wasn't because he was a genius and they were not. It was because he recognized that the where of the space industry had changed. Space was no longer a battlefield for superpowers to show off their flags. It became a logistical frontier. The Russians stayed in the era of heroic engineering, building bespoke, magnificent machines to be sacrificed to the heavens. Musk moved into industrial logistics, building a truck that happens to go to orbit. The final lesson, the variable of death for Roscosmos, was the cost of entry. By the time they realized that reusability was the only way to survive, SpaceX had already captured the market volume needed to make reusability profitable. In any system, whether it's a YouTube channel, a startup, or a space empire, the winner isn't the one with the biggest wet, it's the one who understands the why behind the numbers. If you enjoyed this deep dive into the engineering of the space race, hit the subscribe button and join us as we continue to tear down the blueprints of history. What should we analyze next? The logistics of the pyramids or the math behind the Silk Road? Let us know in the comments. This is What, Where, and Why channel. Thanks for watching.